Wonderful. I'm going to go to fit. I'm going to go to polynomial fit. Fantastic. It looks like this guy is not perfectly flat, but it is what it is. We're going to see what's happening. The A term, B term, C term, and D term. A term, 0.114. B term, a negative 0.0195. The C term is a 0.00399. And the D term is, well, no bones about it. It is 0. It is 0, 0, 0 to it's a 0 to 3 sig figs. Plus or minus, again, we're not ignoring it. It's just that we're not writing it down for our purposes right now. Okay. All of these things happen to have some quality of how well it fits. This is the mean square error. It is an error. So if I do that, I didn't ask for it, but oh, by the way, the MSE, just so I just saw this here. The MSE is 1.18 times 10 to the negative 6. This is 5.98 times 10 to the negative 5. And this is 0.0057, a little bit larger. This MSE, this mean squared error, is exactly the same value as this score that we had over here. So my score, my mean squared error for the velocity run, was 2.564, and then I did it again. 0 is best. It means what actually happened versus what we thought would happen was exact. This was off a little bit. So what we're having here is this mean squared error is telling us how well this polynomial math shape fits the actual data. Okay, so that's or you can think about the other way around. How well did the actual data fit this polynomial math shape? It depends on which came first. A low score means it fits it really, really well. Well, this is 1.8 times 10 to the minus 6. That's 0.50118. That's really low, which means this fits it really, really well. So this polynomial fit fits this data really well. It gives us a good confidence that we really are talking about it. The velocity has a little bit higher score. Instead of being e to the minus 6, it's e to the minus 5. But you'll notice it's a little bit noisier. It's a little bit jumpier. It was rattling around a bit. It was trying to fit this nice, smooth, green mathematical line, but it was all over the place. And then the A term was even higher, as sort of me sort of jerking around when we were trying to do it before, and now the data is jerking around. Here's the math. The math is very smooth. The math just predicts a line. And our error goes up again. It's a little bit worse, but it's still 0.035, which is pretty impressive. Fantastic. These last questions, what we're going to be doing is we're going to be taking these polynomial fit coefficients of A, B, C, and D. We're going to be having a conversation in our class time as to what the heck do they mean. And then once we're able to integrate our math understanding using these polynomial equations with our data observation of what we actually did in the lab, we will be able to answer these questions. So rather than answering these questions right now in the lab section, I'm going to save this. We're going to use this data. This is going to be a conversation for us for the next couple sessions. I just needed this data before we could talk about it. And then when we finish that up, we will answer those questions. So again, I wish you were here to see this. I wish you were here to answer questions that we have. But I think we're good. I'm going to walk over here to the beginning of the lab, and I'm going to press the stop button, and then we're going to take that data and we're going to take a look at it. So I'll see you in a little bit. Thank you.